This is how I made my own file type. First, to make our own file type, we need to take a closer look inside a file. A file is just a bunch of different bytes in different orders. As an example, this decodes to hello world, but that's just text. What about a PNG, JPEG, or any other file? Well, for this example, I'll use the .rgb file, which is an image file composed of just the raw RGB values. So this is just a blue pixel followed by a green pixel. That's the simplest image file out there. Now, let's look at a .bmp file. A BMP file is similar to an RGB file, but it has header information. Header information is just more bytes at the beginning of a file. For example, let's say I have a text file. There are bytes that aren't displayed when it's opened in Notepad. The header could contain information like, make this file's text blue, or everything is bolded. For a BMP file, there obviously isn't bold text, but there are other bytes in the header info. The first two bytes are the signature, which tells photo apps what file type it is. In this case, BMP files always start with 424D, BM. Next is the file size, which is just the total size of the file given in 4 bytes. Then the next 4 bytes are always reserved, or 0. And lastly, for the first header of the BMP file, there is the pixel data offset, which is the byte where the actual pixel data is located. This is encoded with 4 bytes. Now we have the second header, which is a bit bigger, so I will only go into detail for the bytes that matter. The width and height are encoded into 8 bytes. Then there's the image size, which is width times height times bytes per pixel. My RGB example earlier was 3 bytes per pixel. The big difference between BMP and RGB is BMP stores pixels in BGR, not RGB. Each row of pixels must be a multiple of 4 bytes. Let's tweak the padding of this image and see what we get. Yeah, I wouldn't want that to happen to my other photos either. So now that we know how files work, let's try to make our own. The goals I have set for this project are 1. It has to be secure. 2. It can mask any other file. The way I made it secure was by using AES encryption. AES encryption is just a passphrase encryption method. For example, we encrypt the text banjo with the passphrase secret, and we get this. No one without the passphrase can decrypt this. We can decrypt it with the passcode back into banjo. But I want to encrypt a file, not text. We just encrypted text with AES, which is just bytes, and so are other files as we discussed earlier. So we can just encrypt the bytes of this picture of a dog and save that to file.aes, which is the file extension I chose. When we decrypt it, we get the same file back and save it, but a side effect is we don't know what the original file extension was. The way to fix that is to put it at the beginning of our file, like a header. But now another problem arises. We don't know when our header ends. So I put the letters AES, AES, AES at the end of the header in the AES encrypted file. The reason I didn't just put AES once is because that could occur somewhere else in the file by chance and break my script. But for AES to repeat 3 times in a row is so rare that you would need a 2.77 zettabyte file for that to have a 50% chance of happening. That's a 2.7 trillion terabyte file. As for security, which was one of our goals, the chance of someone guessing the key, which when generated is 32 bytes long, is 1 in 10 to 77th power. There are 10 to the 80th power atoms in the whole universe. Thank you for watching this video about files. Please consider subscribing, and I will see you in the next one.